Welcome back, everybody. Before I get into today's lecture, I want to say a few words about the schedule for next week. Next week is going to be a little bit different because Tuesday is election day. It's also a day off, and we won't be having any classes or labs on Tuesday. So that's going to make a couple of changes. The first change is that the practice that I've been following for the last few weeks is that on every Friday, I've been assigning a homework problem that is then due the following Tuesday. Because we're going to be off on Tuesday of next week, today I'm not going to be assigning my usual Friday homework problem. And also, of course, next week, since we don't have class on Tuesday, we're not going to be having a Tuesday lab. What I'm going to be doing instead is that next week's lab exercise is going to be an optional exercise. We're still going to have a lab session, but it's going to take place on Thursday. But the work for the lab session will be completely optional. Unlike every lab session that we've had so far, where you have to turn in your work at the end of the lab session, for Thursday's lab exercise is going to be optional and you won't have to turn in anything. Instead, what we're going to be doing is on Wednesday of next week, I'm going to be introducing all of us to a problem. And then on Thursday, everybody will get together in the lab session. And what I'll do is I'll allow you folks to work with a partner. And in the lab session, you and your partner will work through getting through as much of the lab exercise as you can. And then instead of turning it in at the end of the lab exercise, what's going to happen instead is on Friday of next week in the lecture, I'll be showing my solution to that lab problem. All right, so next week's lab exercise is optional. And if you normally come to lab on Tuesday, what you'll be doing instead is you'll be coming to the same lab time instead on Thursday of next week. So we'll have slightly bigger groups in both of the lab sessions. And what will be happening in the lab session on Thursday is I basically will be allowing folks to pair off and work with a partner, and you and your partner will try to work through as much of the lab problem as you can during the lab session. All right, so that's how next week is going to be a little bit different. All right, now today's lecture is a continuation of something that we were talking about on Wednesday. In Wednesday's lecture, near the end of the lecture, I showed an example of a class that I constructed. That this was a stack class. And the main example that I'm going to show today is an interesting application that makes use of that stack class to solve an interesting problem. All right, so let's go into the materials for today's lectures. The starting point for today's lecture is an example program that appears in the textbook. It appeared several chapters back, but the first thing I want to do is take you through this simple example program from the textbook and talk about some interesting things that are going on in the example program. And then what we're going to do next is we're going to go to work on writing a more powerful and capable version of this program. All right, so this example program that we're looking at here is a simple calculator. Basically, what it will allow you to do is it will allow you to type a very simple arithmetic expression, something like 7 times 5 or 12 plus 14. It's a very simple arithmetic expression that features only two numbers and an operator of some sort. And then the program will go ahead and evaluate that arithmetic expression and tell you the final value of that simple calculation. All right, now this is probably the simplest possible version of this problem, and what we're going to be doing a little bit later in the lecture is we're going to be writing a more sophisticated calculator that allows you to enter more complicated expressions. But for now, this first version that comes from the textbook will only handle very simple expressions where there's just one arithmetic operator and two numbers involved. Okay, now here are some special features of how this program works. The first thing that's special about the way that the program operates is that when it prompts the user to enter their expression that they would like to evaluate, as usual, we're going to be reading the user's input by using a scanner. And this time, the way we're going to read the input is by using the scanner's next line method. That will basically grab the entire line of text that the user types. Right? So for example, if the user types the expression 12 plus 26, the program is going to treat that entire expression as a single line of text, and it's going to read that whole line of text as a single string. Right? Now, the next obvious step is we then need to go to work in breaking up that entire string that the user typed into individual pieces. Right now, in this application where you are breaking up parts of an arithmetic expression into elements and then working with those elements, for this application, those elements are commonly referred to as tokens. So the next thing the program does is it does an operation to take the entire string and break it up into individual pieces or tokens. And the mechanism that we need to make that happen is that there is a special method in the text in the string class. It's called the split method. And what it allows you to do is it allows you to take a single string and break it up into several pieces. And what the split method does is it basically returns an array of strings to you. And each of the individual pieces will appear as one separate string in that array. Right? And then finally, the other thing you need to know about the split method is that when you call the split method, you're expected to pass it a parameter. And the parameter that you pass it is a string containing a set of characters. And any of the characters in that string will be used as a basis for breaking up or splitting the original string. In this case, the only thing we're passing in our string is a single space. That's basically telling the split method that we want to split this string up where the spaces are in the string. Right? So for example, if I type the expression 12 plus 24, most likely what I actually typed was 12 space plus space and then 24. And then the split method will use those spaces in the text that I typed as a basis for breaking that up into three separate pieces. What you'll end up with is an array of three separate strings. You'll have the 12 in one string, the plus in a second string, and then the 24 in a third string after the split operation. Okay, then the next thing the program does is it has to figure out what operation we're trying to perform. And for that purpose, the program will be using a thing called a switch statement. And what we'll be doing is we'll be taking the middle string, which has the operator in it, and we'll be extracting the first character from that string, which is the actual operator that we're interested in. And we're going to use a switch statement to fall into one of four different cases based on which of the four possible operators we're seeing. All right, and then for each of these cases, what we then have to do is we also have to convert the number parts into numbers. In this case, what we do is we take the individual numbers which are stored in arrays in elements 0 and 2 in the array. Those originally are both strings and they have to be converted over to numbers. And one way to do that is to use what's called a parsing method. For example, the integer class has built into it a method called parseInt. And the way that works is if you pass it a string that has an integer in it, it will convert that from text into an actual integer for you. Right, so we use that parsing process to turn the numbers into integers, and then finally we go ahead and do the relevant arithmetic operation on the two numbers. In this case, we're adding them. Here we're subtracting. Here we're multiplying, and here we're dividing. Right, so after the switch statement is done, we will have computed the final result. Right, and the only thing left to do is to print a message that prints the original calculation along with the result that you just computed. And that concludes the simple calculator and the most basic version of computing an expression like this. Okay, now, even though this calculator is very primitive and it can only deal with a single operation at a time, nonetheless, it shows a couple of useful ideas. One useful idea is the use of the split method, which will make it possible to take an entire line of text and break it up into individual pieces so we can process those pieces individually. That's something that we're still going to need in later versions of the program. And the other thing this example demonstrates is the use of these parsing methods that will take a string and convert it to a number for you. That's another essential step that we're also going to need in the more sophisticated versions that we're about to do. Okay, so where we're going next is we're going to go to work on writing a more capable calculator, something that can handle more than just one operation. And eventually, we're also going to add additional special features, such as the ability to add parentheses and other nice things to our expression. And in so doing, we're going to greatly expand the power of this calculator program. Okay, so here's our goal. Our goal is to go from being able to do very simple expressions that involve only a single operator. The next round that we're going to go to is we're going to build a calculator that can handle any number of operations, right? So here's a typical expression that our next calculator will be able to evaluate, something involving multiple numbers and multiple arithmetic operations. That's the next thing we're going to talk about. All right, and then once we have mastered the ability to do something like this, the final thing we're going to talk about is the ability to also add in parentheses. Because parentheses will allow us to control the precise order with which these operations take place, and the final version of the program will be able to handle parentheses along the way. All right, and one quick comment before we start diving into these versions is that in every case, when we start typing in the expressions, one thing that we will have to be a little bit careful about is when we type the expressions, we'll have to make sure that each part of the expression is separated by spaces. So for example, in between this left parenthesis and the 6 that follows it, we have to make sure that we type in a space, because once again, we're going to be using the split method to take the entire string and break it up into individual pieces. And to be able to do that successfully, we need to make sure that each of the pieces has spaces around it so the split method can properly split things up. Okay, so that's where we're going. Next, what we're going to do is we're going to talk about how to handle a situation where there is more than one operation in the expression. Okay, now to do this, we're going to have a specialized algorithm. And one of the reasons that I'm showing you this algorithm today is that the algorithm makes use of a couple of stacks to do its work. Specifically, there are going to be 2 stacks that we're going to be using. One of these is called the value stack, and what we're going to be doing with that is we're going to be placing numbers on that stack. The other stack is called the operator stack, and what we're going to be placing on that stack is the operations, the pluses, the minuses, the multiplies, all of those things are going to be placed onto that stack. Okay, now the algorithm will make use of those 2 stacks, and it's a moderately complex algorithm. So let's walk through an outline of how the algorithm works. Okay, the basic idea in the algorithm is that we're going to be scanning across the elements in the input from left to right. And as we do that, we're going to be encountering both numbers and operators. And the outline here shows things that we're going to be doing. One thing that isn't mentioned here is that when we're scanning across and we come across a number, as soon as we see a number, what we're going to do is take that number and immediately put it on top of the value stack. All right, so that's the first place that numbers go. They automatically go to the value stack. Now, the complicated part of the algorithm is what the algorithm does with the operators when it comes across them. Right, now the first rule to deal with operators says that if you come across an operator and the operator stack is currently empty, the right thing to do is to immediately put that operator onto the operator stack. Now, the next rule governs a situation where you have come across an operator, but the operator stack is not currently empty. Now, for that scenario, there's a number of different outcomes, and the different outcomes are based on, in large part, on what is known as the precedence of these operators. In arithmetic, we have 4 different operators, but they naturally drop into 2 different groups. One group is the plus and the minus, and the other is the multiply and the divide. And mathematically, we say that the difference between the operators in these 2 groups is that they have what's called different precedence levels. The plus and minus operator have a lower precedence, so we would assign them a precedence level of 1. the times and the divide, they have a higher precedence level. They're assigned a precedence level of 2. Right now, what you do with operators when you encounter them is in large part determined by the precedence of that operator. So the next rule says that if we encounter an operator in the input with a precedence that is greater than the precedence of the operator sitting at the top of the stack, we then take the new operator that we've seen and we push it on top of the stack. Right now, the second case deals with a situation where you've come across an operator in the input and its precedence is less than or equal to the precedence of the operator at the top of the operator stack. In that case, what you do instead is you'll take the operator off the top of the operator stack, you'll pull 2 numbers off of the value stack, and using those 2 numbers, you'll go ahead and carry out that operation. And then when that operation is done, you'll take the result of that operation, which is a number, and put that back onto the value stack. All right, that's the situation that applies whenever the next operator in the input has a precedence that is equal to or less than the precedence of the thing at the top of the stack. All right, and finally, the last rule says when you reach the very end of the input and there are no more operators left to read in the input, the last thing you do is you go back to the operator stack, and if there are any operators still sitting on the operator stack, they then are going to get processed. So what we're going to do is do a final series of rounds, and in each round we'll pull an operator off the operator stack. We'll take 2 numbers off the value stack, and we'll do that operation with those numbers, and we'll push the result of that back onto the value stack. Now, at the end of the whole process, after we've read all of the input and we've processed all of the operators from the operator stack, what should happen is there should be exactly 1 number left on the value stack. And that number that's left on the value stack at the end of all of this, that's going to be the result of the calculation. And that's how the calculator actually produces its final result. Okay, now this is complicated enough that I think it's useful to look at an example. All right, so here's a concrete example of how this algorithm operates. Here's an input expression that's already been broken up into individual elements, and we're going to scan across those elements from left to right and evaluate this expression using the algorithm that I've just described. Okay, so the first thing that's going to happen is when we start scanning from left to right, the first thing that will happen is we'll come across that number 2, and we'll immediately place that number 2 onto the value stack. Next, we're going to encounter that plus, and since the operator stack is empty, the only thing to do with that plus is place that on top of the operator stack. All right, and then finally, we'll come across the 3, and again, the rule is anytime you come across a number, that gets pushed onto the value stack. All right, so after we have read the 2, the plus, and the 3, we end up with a situation that looks like this. All right, we process those 3 items from the input, and we now have a few items remaining. Okay, now the next available item in the input is a multiplication, and again, in deciding what to do with that operator, you have to use the rules that I outlined a minute ago. And one of those rules says that if the next operator in the input has a precedence which is higher than the precedence of the thing at the top of the operator stack, what we'll do is simply push that operator onto the stack. All right, so what's going to happen here is we're going to push the multiply onto the stack. All right, so that happens. Next, we see the 4, which is a number, and again, numbers always get pushed onto the value stack. All right, now here we are at this stage, and at this stage, the next operator coming along in the input is a subtraction, which has a precedence of 1. The thing sitting at the top of the operator stack is a multiplication, which has a precedence of 2. And in this case, a different rule takes over. In this case, the rule that applies says that if the operator in the input has a lower precedence than the thing sitting at the top of the stack, what we're going to do here is we're going to process the operation at the top of the stack. All right, and that operation is a multiplication. And to do that multiplication, we'll pull the multiplication off the stack. we'll take two numbers off the value stack. We'll pull off the 3 and the 4, and we'll go ahead and do a multiplication. We're going to do 3 times 4, which will give us a value of 12. And that will result in the multiplication coming off of the stack and then doing the multiplication and pushing the 12 onto the value stack. So that leads us to this picture here. Right now, again, we're back in a situation where there is an operator waiting in the input to be processed. This time around, the story is that the operator that we're about to process has the same precedence as the operator sitting at the top of the stack. And the rule that applies in that case says if the precedences are the same, what we go ahead and do is carry out the operation at the top of the operator stack. Right? So in this case, we have a plus. We'll pull that plus off the operator stack. We'll pull two numbers off the value stack to go along with that, and we'll do an addition. So we're going to do 2 plus 12, which gives us a result of 14. All right, that leads to this situation. All right, so now finally we can do something with the minus because we're back again in a situation where the operator stack is empty. And whenever that happens, any waiting operator will go directly onto the operator stack. And then the next number that comes in also goes automatically to the value stack. All right, and finally, the rule that takes over here is when we have reached the end of the input, the last thing that happens is we remove any remaining operators from the operator stack, let them do their operations, and push their results back onto the stack. All right, so in this case, we're going to be doing a subtraction. We're going to be doing 14 minus 6, which has a result of 8. And that is the final result here. And at this point, we have successfully concluded the algorithm. We have processed all of the operators. There are no operators left. There's nothing left in the input. And at the end, we have exactly what we're looking for. We have exactly one number left on the value stack, and that is the result of the whole arithmetic operation. Okay, so that's an example of how the entire algorithm works, and along the way, how it makes decisions about what to do with the operator stack. In some cases, it'll be pushing new things onto the stack. In other cases, it'll be pulling things off of that stack and evaluating them. There's a complete set of rules to handle every possible scenario for what could happen here. Okay, so let me pause at this point and ask if anybody has any questions about how the algorithm itself is operating and how it does stuff. Okay, so what comes next is we're going to start to dive into the details of implementing all of this in code. And to help us out with this, the first thing that I did in the lecture on Wednesday is I showed you how to build a stack class, and we're going to need to use a couple of stacks in this algorithm to do all the work that's necessary. Okay, now one quick comment about the stack class that I built last time and what we need to do here. The problem this time around is that the stack class that I built for us last time is capable of storing integers. So for example, we could use that stack class to store the values in the value stack. But unfortunately, a stack that can only hold integers won't help us with the operators, right? Because the operators are actually going to be expressed as characters and not as numbers. Right, so that is a potential problem because the stack class that I built is designed to store one type of data, and that would work for the value stack, but it won't work for the operator stack. Right, well, let me show you a trick that you can frequently do in Java programming, and this is a trick which is useful in any scenario in which you have built a data structure which is capable of handling a certain type of data, but then you suddenly need it to handle a different type of data. Here is a very slick mechanism in Java that you can use to work around that problem. And the mechanism is this. We're going to make use of a new feature in Java. It's called the Java Generics feature. And what the generics feature allows you to do is it allows you to create objects and data structures that can handle different types when you use them. Right? And here is an example of how this is going to work. If you'll recall from Wednesday's lecture, the way that I built my stack class is I first created a simple class called a stack item class. And that stack item class that I designed on Wednesday was capable of storing integers. Now, for this application, we want to be a little bit more flexible. We want something that can't just store integers. We want something that can store just about any data type that we would like to work with. Well, the key to doing that is to write what's known as a generic version of your class. Right? And the trick for doing this is when you're declaring the class, the first thing you do, which is a little bit different, is you declare this to be a generic class by putting a little something extra after the name of the class. What you do is inside brackets, you list a special value called a placeholder value. Right? Now, the purpose for this placeholder value is that it is essentially a placeholder for a type. And what this is saying is that this class that I'm about to create is going to be making use of a particular type, but I'm not going to tell you right now what that type is. The only thing I'm going to tell you is to use a placeholder for that type. And in this class, the placeholder is just this letter E. Right? Then when I go ahead and write the code for this class, at various locations where I would be expected to specify a type, I'm instead going to be using that placeholder, right? So here, for example, I'm going to be setting up a member variable. Now, normally when you declare a member variable, you have to declare a type for that member variable. And in the original version of this class, that type was int. All right, well, what I'm doing this time around is I'm replacing that type with a placeholder, saying this thing is eventually going to be capable of working with different types for the value. And for the time being, I'm just putting a placeholder in where the type is supposed to go. All right, and in other places, I'll also be using that placeholder. For example, when it comes time to write the constructor will take one parameter, which is going to be a value that I want to store in this item. And again, since I'm not going to give this thing a concrete type, I'm going to be using the placeholder as the type for the parameter. And as long as these things are consistent, and as long as I'm using E for the parameter and I'm also using E for the value, this is now perfectly valid Java code. Right, so this is the first step toward making a stack which is a little bit more flexible. To make a stack which is capable of storing different types of things, we're going to start by making a generic stack item which is capable of storing many different types of values. And this generic mechanism will now make our stack item class more flexible. Right? And then as soon as you've made your stack item class more flexible by making it generic, we also do the same thing for the stack class itself. Again, we declare this as a generic class that's going to be making use of a placeholder. And in various places, we use that placeholder in place of an actual type. And then we do this all in a fairly generic way. Right now, what all of this accomplishes is this makes it possible for you to make stacks that can store different types of things. And here's what that will eventually look like when we get around to making the different stacks that we need. For example, in our program, I need two different stacks. I need a value stack that can store numbers. So for that purpose, I basically replace the placeholder with double. All right, this is going to make a stack that is capable of storing a bunch of doubles. And then for the operator stack, what I need instead is a stack that is capable of storing individual characters. So when I declare that stack, I say, okay, what I want here is a stack that can store characters. Right? And then once you use the right types for the two different stacks, everything will just work the way that you want it to do. For example, if you want to go to the value stack and if you want to push a number onto the value stack, you simply say, here, push this number. On the other hand, if you want to go to the operator stack and push a character, you simply say, here's a character, push that onto your stack. All right, and that generics mechanism makes it possible for me to have one type, which is the stack type, but then make different flavors of that type that are capable of storing different types of data. And that is exactly what we need for this application. I need one stack that can store doubles, and I need a second stack that can store characters. That's the key technical thing that we're going to need to make this all work. Okay, now at this point, I could go ahead and show you the code for the calculator that is capable of handling multiple different operators. Um, the reason I'm not going to show that to you is our time is a little bit limited today. So what I want to actually do is I want to jump ahead to the final version of the program. And that is the version that is capable of not only doing what I've shown you here, but it's also capable of handling parentheses. Right, so let's quickly say how the algorithm needs to be modified if you're also going to be mixing in parentheses into what's going on here. Right, so here are a couple of additional rules that tell you what to do with parentheses if you come across them in the input. Right, the first rule simply says that if you're scanning across the input and you come across a left parenthesis, all you simply do with that is whenever you see a left parenthesis, it will immediately go onto the operator stack. Right, so that now simply becomes a different type of character that we can push onto the operator stack. Right, and the simple rule is all left parentheses immediately go onto the operator stack as soon as we see them. Right, now when we're scanning across the input and we come across a right parenthesis, a right parenthesis is basically a marker that marks the end of a particular calculation. So what we'll want to do is go ahead and do that calculation. So what we do next is when we see a right parenthesis in the input, what we'll do is we'll go to the operator stack and we'll start pulling operators off the operator stack and doing their operations. And we'll continue that until the thing that appears at the top of the operator stack is the left parenthesis that is supposed to match this right parenthesis. And then as soon as the left parenthesis appears, what we're going to do is pop it off and throw it away. And then we're also going to throw away the right parenthesis that went with it. That's how we're going to be doing processing using parentheses. All right, so again, two simple rules. If you see a left parenthesis, push it on the stack. If you see a right parenthesis, keep processing things from the stack until you see the left that matches the right, and then throw away both of the parentheses, and then you're done. Okay, so that is the final set of rules that you need to also to be able to handle parentheses. So now finally, we're in a position to show the full program. All right, so let me switch over to NetBeans now and show you the program for the full calculator. Okay, so first of all, this calculator is going to be implemented as a class. And since the algorithm needs to make use of these two stacks, I have decided to basically make those two stacks member variables in this class. And the main thing that we're going to be adding to the class is a collection of methods that will allow us to process all of the input that we're going to be processing. Right? And the most important of those methods is this one right here. It's the process input method. This is the one that allows you to take a string of text that the user has entered, and it does all the work of processing that. Okay, now, because this is a moderately complicated algorithm, the process input method is going to be fairly complex. As you can see, it covers quite a few lines of code here, starting from line 66 and running all the way down to line 121. Again, because this is a fairly complex algorithm, it takes quite a lot of logic to write out all of the details in the algorithm. Right, and even more than that, another sign of the fact that this is such a complex algorithm is that I've also felt the need to write some additional so-called helper methods to help us do certain key steps in the algorithm. For example, one very important step in the algorithm is the step where you have just popped an operator off the stack and you need to go ahead and carry out that operation. To do that, I've written a completely separate method that does just that one step in the algorithm, where you have an operator and you need to go ahead and process that operator. That's sufficiently complicated that it really should be given its own separate method to do that key step in the algorithm. Another pair of things that we have written to be helpful is some other helpful helper methods. One of these is a method that checks to see whether or not something is an operator as opposed to a number or something else. Another helpful method is a method that can take an operator and tell me what its precedence is. So here we have some simple logic that says the precedence for pluses and minuses is 1, and the precedence for times and divides is 2, right? Again, this is all sufficiently complex that it's useful to write a bunch of additional methods to make the work go more easily. All right, and finally, the last ingredient here is a main method. The main method itself is fairly short because most of the real work is going to be taking place in the process input method. But what happens in main is we set up a scanner, we prompt the user to enter an expression, we read the line of input that they've typed, then we create a calculator object, and then most importantly, we call the process input method on that calculator, and that will do the actual work of processing the expression that the user entered. All right, and again, most of the heavy lifting in this code is going to be in that process input method. This is where all of the processing is going to take place. Okay, so now let's take a quick dive into the process input method and see some of the key things that are going on here. The first essential step is that when the input comes to you, it's going to come to you in the form of a single string that has everything that the user typed. And once again, the first step will be to break that up into individual elements. All right, so again, we'll be using the split method to break the input up into individual pieces, and we'll be storing those pieces into an array of strings. Right, then the key part of the algorithm is where we read across those elements from left to right, and to do that, here is the main loop in the processing code. This is going to go across the elements one at a time, and on each round through this loop, we're going to be taking one element off of the input, and we're going to be doing the right thing with it. Right, so for each element that we pull off, we're going to be extracting an element from the list, and then we have to determine what type of thing we're going to be seeing, because we can see either a number, a parenthesis, or an operator, and there are different cases for each of those different things. All right, so to determine what we're dealing with, what we have to do is take the first character of the string that we've just pulled off the input, and then we have to do a series of if statements to see what we're dealing with. Right? The first possibility is that we come across something that looks like part of a number. In that case, what we'll do is we'll take the entire element that we were just given, we're going to run it through a parsing method and turn it into a number, and then all that simply happens when we come across numbers is that they go directly onto the value stack. Right? That's the logic for numbers. Now, the next case is an operator of some sort. Right? And this is where the full logic of the algorithm comes into play, because there are several different cases for what can happen when you come across an operator, and there is logic here that handles every possible scenario for what could happen when you come across an operator. You're either going to end up pushing that operator onto the stack, or you're going to end up pulling things off of the stack and processing them. And there's full logic here to handle every one of those cases. All right, and finally, the last possibilities are that the next thing that you encounter in the input could be a parenthesis of some sort. There are two cases for that. If it's a left parenthesis, that goes simply directly onto the operator stack. And the final case is that if you come across a right parenthesis, we have this rule that says what you need to be doing is you need to keep processing things from the operator stack until you see a left parenthesis. All right, so here's a loop that continues doing the processing until there are no operators at the top. And then finally, if we've reached the end and then there is a left parenthesis, we simply pop that off and remove it. Okay, and then finally, when this loop ends, this loop will end after we have processed all of the input. And then at the end, when we have processed all of the input, there may still be some things sitting on the operator stack that need to be processed. We have a final loop here that takes care of doing that. And then once that loop is concluded, we simply do some final checks. One final check is to check to see if we came across an error anywhere along the way. And built into the logic that we see here, there is some additional logic that's checking for error situations. And whenever an error occurs, it will set a special member variable to true so you know that an error has taken place, right? So if we reach the end and we've seen no errors so far, the last thing to do is to look at the thing at the top of the value stack. That should be our result. But then we've got one final check, and that is after we've removed that result, we also need to check to see that both of the stacks now are empty. And if there's anything left on either of the stacks at this point, that means that there's some sort of an error going on, and we need to print an error message. All right, but if everything has gone correctly here and there are no errors, what will happen is we will have removed the last item off of the stack, and that will be the result of the calculation. All right, and then if everything goes correctly and there are no errors, the last thing we'll do is simply print the result. Here's the final result of the calculation. Okay, so there you have it. This is probably one of the most complex examples we've seen so far. And again, it is complex because we're dealing with a moderately complex algorithm that has to handle a variety of different scenarios and different cases to be able to fully process anything that we might encounter in an arithmetic expression. Okay, any questions at this point about anything that you see happening in the code here? Okay, one quick thing to point out here is that in the lecture notes for today's lecture, I've posted the project that you're just looking at the top of the lecture notes. So if you'd like to review this code yourself, go ahead and download that project and have a look at it. And then one final thing we'd like to do with this example today is simply run this and see what it does. All right, so let's go ahead and run this evaluator and see that it can evaluate a number of expressions ranging from very simple expressions up to more complicated expressions. All right, so here's an example of a very simple expression. Let's do a division, 125 divided by 36. All right, and again, since the calculator uses doubles for all of the numbers, it will be able to correctly handle a division that produces a non-integer result. All right, so that's one very simple example. The next example is an example that involves several different operations. So for example, we can type 34 minus 25 times 12 plus 33. And again, by using the precedence rules, this will do the operations in the right order. When you evaluate an expression like this, you have to use the precedence rule that say the first thing you'd be doing is multiplying the 25 and the 12. And then after doing that, you would be doing the subtractions and the additions from left to right. Again, this algorithm is powerful enough to do all of the right operations in the right order, and it will produce the right result in this calculation. Okay, and then finally, our last example is an example involving parentheses. Again, this algorithm is now sophisticated enough to be able to do the right thing when it encounters expressions involving parentheses. Let's start with a simple example. Let's do an example that involves various operations, including additions and divisions. All right, and again, that gives the right result, taking into account the presence of the parentheses and the operator precedence and everything like that. All right, and then a final example here is a very complicated example with all kinds of crazy combinations of operations and parentheses. Oops. Divided by, let's say, 23 plus 12 minus 6. Okay, and if I've got the right set of parentheses and everything, that should be able to evaluate. Boom. Okay, sorry. This is very hard to get right because I forgot to type the space between that 6 and the parentheses. Sorry. Let's try this again. Let me cheat and copy this and do this a little bit faster. All right, so again, we need to make sure we have a space between the 6 and the parenthesis, and then one final parenthesis. Okay, expression error. Ah, darn it. Looks like I missed a parenthesis here. Let's try one last time. because this calculator is clearly smarter than I am. Oops, I copied the wrong thing. Darn. Oh, that's too bad. Oh, well, let's call it a day. I think I'm going to declare defeat at this point. But at any rate, this calculator, as long as you enter a valid expression and you remember to put spaces in the right places, this will be able to handle anything that you throw at it now. Okay, so that's the end of today's example. It's also the end of this week. So come on back on Monday, where we're going to be talking about some additional interesting classes to work with. And then in the latter half of next week, we're going to be introducing another situation where we have a mildly complicated problem to solve and an algorithm that will solve it. And we're going to be working together to solve that problem in the lab exercise next week. Okay, so until then, everyone have a good weekend, and we'll see you all back again on Monday.
Thank you.
Thank you.
Bye-bye, everybody.
Thank you.